is equal to b squared plus c squared minus 2bc times the cosine of a. Do you guys remember doing this last year? And it's on your trig note card, isn't it? You have this formula on your trig note card. So Robert, I don't know what your trig is. Did you do this?
Yeah.
Okay.
I just forgot.
You forgot. And that almost everybody does. That's why I like this problem, because it gives us a chance to review these ideas of what are the law signs good for. When do you use the law signs instead of law cosines? What's that? In other words, I'm going to draw, just forget about this problem. We're just going to digress for a moment. Here's a triangle. This is 27 degrees. This is 18. And this is 26. We'll call it triangle ABC, just to be unique. Law of signs solution or law of cosines? How many know? You want to take we just vote. How many say law of signs? Raise your hand. How many say law of cosines? Raise your hand. It's okay to be wrong. Law of signs, law of signs is easier to compute, but you have to have a matched set. You have to have a side and the angle opposite it in order to make it work. Do you guys remember that? So we would say 18 over the sine of 27 is equal to 26 over the sine of its opposite angle. Once I know this angle, once you know two angles, you know all three. Once you know this angle, you can find the sine. So law of signs is always easier to compute, but you don't have a matched set. I mean, if you don't have a matched set, you can't use the law of signs. So in this case, since I have the angle in between these two, I set it up as a law of cosines problem. So, are you okay how I wrote it this way and why? Let's clean that up a little bit. I've got d squared is equal to 1 plus p squared minus 2p. What is the cosine of 120? What's the cosine of 120? Alexis? I'll draw it for you. Fair enough? 120 right here. What's the reference angle for 120?
30.
Is it?
No, 60.
It's a 60. So x is short, y is long. Negative 1/2 is the cosine at 120, and certainly you could use your calculator to get that, but so, oh, that's nice. These two's cancel, and I get plus p here. So I end up with d squared is equal to 1 plus p squared plus p. Questions? Function, help me out with the derivative. Take the derivative with respect to time. What do you get?
D 2D
2d
D
d dt equals,
1 plus
hold on,
no 2p
2p yeah,
plus
dp dt, even funner to say, dp dt. Go on,
plus dp
plus 1 dp dt. I know dp dt, don't I? I know how fast that plane's flying. It's flying at 300 kilometers an hour. I know how far the plane's gone. We calculated earlier in the problem. Didn't we say this had traveled 5 kilometers? I'm looking for d dt. I'm going to divide out the 2d. So d dt, the change in the distance between the plane and the radar station, is 2 times p. And we said in the 1 minute this is going to travel 5 kilometers times dp dt, which is 300 kilometers an hour, plus dp dt, all divided by 2 times d. What's d? When this is 5, right, when I actually plug in, when I freeze frame it, when that is 5, what's d? How do I find it? Can I just plug 5 in here and get d? D squared is equal to 1 squared plus 5 squared minus 2 times 1 times 5 times the cosine of the angle between them. We did a ton of these in our trig class, didn't we? D squared is equal to 1 plus 25 minus 10 times negative 1/2. I get the square root of 31. Crunch it all out and tell me how fast it's going, how fast they're changing. Ooh, stop. I got a problem. Well, actually, I don't. I'm okay. Does it ask specifically for units of time? What does it say? Okay, 1 minute later. So I think we could give our answer this way. We just have to be careful with our units of time. Okay? Help me out. What have I done? What are my units that I'm using here for my 300 kilometers per? These are an hour. So when I get my answer for ddt, it's going to be in kilometers per hour. I think the answer I read to you was one I did in kilometers per minute. And it doesn't matter. They're both correct answers as long as they're labeled correctly. So what do you get when you do this? 1,500 over the square root of 31, whatever that is. Help me out here. 296.35, and that's in kilometers every hour. And I think I did it in kilometers per minute. I think what I did is rather than 300 kilometers an hour, I plugged in 5 kilometers every minute, which is the equivalent. And I got it in kilometers per minute. Either one would work for me. Yes?
I have a question about your conversion.
About what?
Right there, your conversion.
Roger that.
What happened to the minutes? So that it's 5 kilometers per
Oh,
minute, right?
good question. I don't want to say it that way. How about if I say it this way? 300 kilometers per hour distance, or rate. Well, let's go this way. I want to know how far it went. So I have to say the rate at which it's traveling times the time at which it's traveling, right? So you need to change minutes. 1 minute is 1/60th of an hour. Does that make sense?
Yeah.
So then it's going to cancel out. So you're going to replace this with 1/60th of an hour. So the hours will cancel out. 60 will go into 300, give me my 5. That's a better way to think of it, okay? Distance equals rate times time. Is that reasonable? Here's the thing. All of these are harder questions, but every one of these you guys have the skills to do, don't you? But to do these last few, you're connecting the dots a lot farther back. You've got to go all the way back into your trade class to be able to do this one. I'm not saying any of them are easy, but I'm saying that all of them are within your ability to do this. You guys shoot way too low. You're much smarter than you give yourselves credit for. When you come across a problem that's hard, you guys should embrace it. You should say, okay, let's get dirty here. Let's find out what this thing's all about. Tug on it, push on it, find out what makes that problem work. Okay? Let's look at the back side of this thing. Length of the rectangle, that'll be easy. Laterally in against the wall, that'll be easy. 3 relates to 2. I'm looking at these. These are pretty close, right? A spherical balloon, a bolt being pulled into a dock, water drain from a conical reservoir. Look at number 8. Number 8 is the balloon rising while the car passes underneath it or whatever it might be. This is like the one we did yesterday, right? How you define your vertical piece will make a difference on how the problem works out. A kite flying. 10B is going to be the hard one on this, okay? Read 10B. What is it? We have to find out how far they were. Does it matter how fast they're changing on that B part? No, we're looking for the minimum distance between them, aren't we? So part B is actually an optimization question based on the picture you set up for A. Do the ships ever catch sight of each other? You want to minimize the distance. And it says that the visibility that day is so many miles. What is it? 5 miles? So if the minimum distance is greater than 5 miles, then the ships could never see each other. But if the minimum distance is less than 5 miles, so we've kind of thrown an optimization question in with that related rate. Everybody's good with that? Okay, we'll talk about these tomorrow. Dig in.